Hello, everyone, and welcome to the first video of our second ICE Day. Today, I'm going to start by talking about something I should have mentioned when we were talking about the imine formation mechanism. But to get there, I want to take you back to the acetal formation mechanism. And as I'm sure you remember, I made a big deal about the hemi, in other words, the hemiacetal that is in the acetal formation mechanism. The reason I did that is because I wanted that to serve as a guidepost. If you remember that you have to make a hemiacetal halfway through the mechanism and that it reacts further to get all the way to products, it's a useful way to make sure that you're on the right track when it comes to this mechanism. Well, it turns out there's an entirely analogous intermediate in the imine formation mechanism, and it's referred to as an aminal. In fact, if you look at the aminal structure, you will see that it is very similar. So you've got an OH group and you've got an amine in an overall neutral molecule. So this can serve as a useful guidepost. If you remember that you're going to have to make an aminal intermediate when you're doing the imine formation mechanism, that'll help you keep everything straight. And a lot of people have an easy time remembering this because if you think about it, aminal is kind of difficult to pronounce. But in reality, it's exactly what toddlers will say the first time they're trying to say animal. So what they say is, hey, look, it's an aminal. Well, anyway, I don't know if that helps you remember it or not. But what I want to talk about next is a reaction that's referred to as reductive amination. Reductive amination is an interesting process in which we reduce the CN of the imine that we're going to form, but as it reacts in the reaction. And we do that by adding the reagents hydrogen and palladium, or a special borohydride reagent called sodium cyanoborohydride. It's either or, you don't use both. And one thing I want to emphasize, this is not a situation where you carry these out sequentially, where first you make the imine, then you add the hydrogen and palladium or sodium cyanoborohydride. You mix these all together, and that's what's kind of cool about this reaction. So for example, if we take an aldehyde and react it with an amine, the first thing that's going to happen is it's going to create an imine according to the mechanism we just talked about. But it turns out that imine is very reactive to either hydrogen and palladium or sodium cyanoborohydride. And what we're going to generate as our final product is not the imine, but rather, let me get it right this time, but rather the amine as a product. So it's a really cool process because we can start with an aldehyde and amine, and we can end up with a more complicated amine. And there's a whole chapter that we're going to talk about later in the semester. You'll see how useful these amines really can be. Now, many of you may have been wondering, now, wait a minute, doesn't hydrogen and palladium react with the carbonyl directly? Well, the answer is yes, but not as fast as it reacts with carbon-nitrogen double bonds. Those are more reactive. And the imine formation mechanism is so fast, it outcompetes it. The same is true of sodium cyanoborohydride. It actually doesn't react with carbonyls, but it will react very quickly with carbon-nitrogen double bonds. Okay, I hope this was helpful.